Welcome back. We've been talking about rate of change and slope. In particular, in our last video, we looked at rate of change. In this video, we are going to look at slope, which is a specific kind of rate of change. Slope is going to be the rate of change of a line, and a line has a constant slope for the entire length of the line. So if we have a line, our slope equation is exactly the same as our rate of change, delta y over delta x, but this delta y we can represent using our ordered pairs. So we pick any 2 points on our line, x1, y1, and x2, y2, and we find the change in our y values, which will be y2 minus y1, and we divide it by the change in our x values, x2 minus x1. So you might have heard rise over run phrase used. That's the change in y is the rise, and the change in x is the run. We have to remember that positive rise goes up and positive run goes to the right. In order to keep this straight, you want to make sure that you have ordered pairs stacked. So we want y2 over x2 and y1 over x1. So in this video, we are looking at slope. The first example I want to look at is just the slope of 2 points. So find the slope of the line that passes through the points -4, 3, and 2, 5. So I'll say that this is my x1, y1, and my x2, y2. It really doesn't matter which point you define to be point 1 and which point is point 2. Your equation will work out the same either way. So my slope, which we will refer to as m, is equal to y2, which is 5, minus y1, which is 3, over x2, which is 2, minus x1, which is -4. Couple things to be careful of. 5 over 2, those two go together. Positive 3 over -4, those go together. The next thing is that I'm subtracting a negative number, so I want to make sure that I remember to add that. 5 minus 3 is 2. 2 minus -4 will be 2 plus 4, or 2 over 6. I can simplify that to be 1/3. This is a positive slope, and a positive slope is going to go in the up to the right direction. So positive slope is up to the right. I rise positive and run positive. So I can think about this line as for every rise of 1, my graph will run 3. And I could draw my line like that. Another example, we have an actual graph here. So I'm going to need to pick ordered pairs off of this graph. So find the slope of the line. I see I have 3 points on here. I'm going to call them all out. This point I see is 0, -3. This point is -2, 0, and this point is -4, 3. I can take any 2 points on my graph. In general, I like to include a point with 0. It makes my math a little bit easier. I'm actually going to take these 2 points. Doesn't matter which you define to be x1 and or which point you define to be 1 and 2. I'm going to define this point to be 1 and this point to be 2, just to keep things, just so I know which is which. So my slope here is equal to y2, which is 0, minus y1, which is -3. Make sure you put that in parentheses, because the negative minus a negative, divided by x2, which is -2, minus x1, which is 0. Ordered pairs are stacked. I have the ordered pair -2, 0, and the ordered pair 0, -3. It's really easy to make a mistake and flip these, and then you won't have the correct slope. 0 minus -3 will be +3. -2 minus 0 is -2. So this is the slope -3/2. Negative slopes are going to go down to the right. So just by looking at my graph, this is a negative slope. Any graph that goes down to the right, that's a negative slope. So I have the right sign on my slope, And I could check this out. If I rise positive 3 from this point, 1, 2, 3, and run negative 2, I end up getting to this point on the line. If I rise negative 2 or negative 3 from this point and run positive 2, I end up getting to a point on the line. So that is the correct slope of the line. In this example, find the value of r so that the line passes through each pair of points and so that the line that passes through each pair of points has the given slope. So in this case, I know the slope, but I have an unknown y value in my line. This could be an unknown x value, it could be an unknown variety of things. But I just want to go through my formula, which is m is equal to y2 minus y1 over x2 minus x1. I'm actually going to make this point 2 and this point 1. So my slope is equal to 2. My y2 value is r. My y1 value is 3. So that's r minus 3 in the top. The x value that goes with r is 6, minus the x value that goes with 3 is 3. There's only one unknown in this equation, so I can go ahead and solve this. I'm going to simplify things first. So I have 2 is equal to r minus 3 divided by 3. To get this 3 out of the denominator, I'm going to multiply both sides by 3, giving me 6 is equal to r minus 3. I will add 3 to each side, 9 is equal to r. And if you check this with 9 in here, you'll get that it actually does work. So that is the slope, or that is the value of r, so that a line passing through these points has a slope of 2.